Hello everybody, so this is gonna be a review of chemistry. So, if you've already studied chemistry a bit, all you need is just a bit of background knowledge, and then you'll be able to understand this. And you might catch on if you're able to, even if you don't have any background knowledge, just try to understand. It might not be as easy, but okay. So, first, we need to draw an atom. So here's the nucleus of an atom. Here are these are called shells. The three shells they don't look very neat. Let me redraw them. That's a bit better, I think. Okay, so there are three shells of an atom, each with an amount of electrons. So let's draw the electrons. Make them different color. Let's make them green. There. So one electron in this is called the outer shell. And then let's say 3 electrons in this one and 1 electron over here. So this one in the outer part of the atom is called the outer shell. Outer shell. Should be easy to remember. It's the outer part of it. So the goal of an atom is to have a full outer shell of electrons. So the outer shell can hold up to 2 electrons. Okay, so but right now you can see it only has 1. So its goal is to get 2 in this shell. It's called the outer shell. The inner ones, like this one and this one, they can hold up to 8 electrons. But the atom wants a full outer shell, so 2 electrons in this outer shell. So there are different ways to get there are different ways to get 2 electrons. Most of them have a downside, but the main goal is to get 2 electrons. That's the atom's goal. So the way atoms get extra electrons are through bonds. So first we'll be talking about covalent bonds. So now covalent bonds is where another atom is involved. So let's see this atom over here. Hi, my name's Adam. Okay, so that was really bad, but so this atom also has 1 electron, and it's looking for more electrons as well. Let's say it has like 3 over here, and then wait, I forgot. Okay, I forgot to make this. Okay, so this is the other atom. So if they can share these two, then they'll both. You'll see what I mean soon. So if they could share these 2 electrons, then they'll both have 2 electrons. They'll be like joined together, but at least they'll both have 2 electrons. So now I'm going to show you what I mean by that. So I'll just quickly erase that. If they join together these 2 atoms like this, and then you see how this atom had another electron. Now they're part of both. You see how it's like in the same. They're part of this atom, but they're also part of this atom. So in that way, they both have 2 electrons. They're stuck together, but they have 2 electrons. That's called a covalent bond. That's the strongest bond of all the bonds. So now they can share those 2 electrons because now they both have 2 electrons in their outer shell, and they've achieved their goal. But what if this atom, for example, let me just erase it now. So what if there's another atom with here, and instead of 1 they have 2. So this atom is a happy atom because they have 2 electrons in their outer shell. You can see outer shell, they have 2 electrons. So for this atom, our atom, to get 2 electrons, you can take this one, right? So now this atom doesn't have its electron anymore. Okay, goodbye. And it goes to this one. Yay! And that's another way to get 2 electrons. That's called an ionic bond. And I'll tell you why that's not as strong as a covalent bond. It seems so easy to do, but now we realize that there is, in the nucleus, this white thing, this nucleus, let's do a different color. There are protons, and protons always equal the amount of electrons there are. So let's see how 1, 2, 3, 4, 5. So there was 1, 2, 3, 4. There was 5 protons in this atom, but now our atom took an electron from this one. So now it's not balanced because protons and electrons ideally should always have the same amount. So originally there was 5 protons and 5 electrons, but now we have an extra electron. So now this atom it's called a negative charge. this atom is negatively charged. And same thing with this. So this atom over here that used to have 2 in its outer shell and 1 over here, so which means it had 3 protons, because 1, 2, 1, 2, 3, right? But now that it got that one taken away, it has 3 protons and 2 electrons, which makes that one positively charged, because now it has more protons than electrons. So that's bad for both of them. But they still, well, it's bad for, usually it wouldn't be you just steal it, like they both atoms would benefit from this. In my example, this atom didn't really benefit at all, because now they just don't have an outer shell. But usually they'd both benefit, they both have 2 at their outer shell. But then this one is positively charged and this one is negatively charged, which is, like, not good. I'll explain that later, okay. And then there's finally one more bond, which is the weakest bond of all of them, called a hydrogen bond. But I won't cover that in this video because it's a bit complicated. Now we're going to be talking about electronegativity. Not electromagnetivity, electronegativity. So electronegativity causes, so let's make a covalent bond again between, so for example, this little atom over here and this little atom over here. They made a covalent bond, yay. We'll just make their inner shell and outer shell, they're sharing those 2 electrons. Okay, so these 2 are happy, but electronegativity causes these shared electrons in this example over here, these 2 shared electrons, it causes them to get pulled towards one atom more than the other. So if this atom has a higher electronegativity, these 2 electrons will be pressured to, I should probably use a different color. These 2 will be pressured to move towards that atom's away from this one. So now it's not really, it's still balanced, covalent bond is still the best, but it's getting pushed towards this atom because this atom has a higher electronegativity rate. So each element has its own electronegativity. So these 2, like, electrons I'm talking about, whatever. So if it was, for example, oxygen, which has a high electronegativity rate, then it'd be, if this one has oxygen, that's not, that's oxygen in here, and for example this one has like something like hydrogen, which is lower, then it'd be pulled towards the one with oxygen in it, because it has a higher electronegativity rate. So, and that way, it gets a sort of, this one gets a sort of negative charge because the electrons are going towards it, and this one gets a sort of positive charge. Not as much as this example over here, because in this example, you just straight out took the electron over here, which makes it negative, and this one just straight out lost an electron, which makes it positive. And remember, what makes things positive and negative is the amount of protons. So this has 3 protons, so like 1, 2, yeah, so 3 protons, this one has 2 protons. Now that it's getting pushed away, this one would have more like, it'd be more like 3.5 total electrons, so that'd be a little bit of a negative charge, and then this one is getting pulled away, which means it's losing some of its electrons, and then the protons are not equal to the electrons, so this one would get a little bit of a positive charge because of the more protons. And then that's pretty much it, and then there's just ways to, like, represent chemical structures, like there's ways to, like, instead of drawing it like how I did over there and there are other ways to do it. Like, for example, if we go up here, I can show you, this is called a molecular formula. So, for example, H2O, most of you should know that H2O is water. That's how you make water. It's 2 hydrogens and 1 oxygen. That's called structural, that's called a molecular formula. That's the easiest way to write it, it's just words. Then there's a structural formula, which is, you, like, actually draw it out like this. This is like that, there's hydrogen over there, or whatever, so then you, like, draw it out like this, how I did over there. Then there's, like, 3D structural, like, it's not really that important, it's just, like, how you try to make it more, like, realistic, some people do, and there's, like, a ball and stick model, it's like this, and you, like, make balls coming out of it like that, and stuff. And then, yeah, and there's space filling model, just, like, how it actually looks, kind of like in real life, something like this. Something like that, it would look like. And then, yeah, so, and there's just, like, a digital model, it's easy, it's, like, interactive, it's like that. Okay, so, that's all. I hope this video helped you to understand, just review chemistry if you've already studied it, or maybe learn a bit more if you haven't studied it yet. But, yeah, that's the video. Okay, bye.